that our variance of x is equal to the expected value of x squared minus the expected value of x all squared. We should recall that our expected value of x is equal to 1 all over p. We also have our expected value of x squared is equal to what we got there, p plus 2q all over p squared. So to obtain our variance is just to substitute what we have for the expected value of x and the expected value of x squared into the variance. So how do we go about that? We write our variance of x is equal to the expected value of x squared, which is this, is p plus 2q all over p squared minus our expected value of x is 1 all over p. 1 all over p squared. So we can open this. For we to open this, we'll move over to the other side of the board. For we to open that, we'll move over to this side. Now we have our variance of x to be equal to p plus 2q all over p squared minus 1 all over p squared, which is also equal to the LCM of p squared is p squared. All we need to do is just to bring out this. This will now give us p plus 2q minus 1. So that is what we get. So what do we do next? Of course, this is our variance. What do we do next? We can open this to say p plus 2q can give us q plus q minus 1. Nothing has changed. All over p squared. All over p squared. Now, we know from probability that p plus q is equal to 1. So we have that 1. Okay, let me write it out. This is our variance of x. From probability, we recall that p plus q is equal to 1. It then means that our variance of x will now be equal to 1 plus q minus 1 all over p squared. Of course, we have something reasonable there. Of course, 1 will cancel 1 to give us q all over p squared. So this becomes our variance. This becomes our variance, which is q all over p squared. So this is how we can obtain the variance for the geometric distribution of the moment generating function. This is how we can obtain the variance. We've obtained the expectation, we've also obtained the variance. The variance is q all over p squared. When we follow this procedure, it will be very easy for you to compute the variance of the moment generating function. For more on this topic, you need to subscribe to this channel.